Hey, space fans. Um, you're probably wondering why we're hanging out, just kind of floating, just floating with this big green booger hanging out right here. Well, I'm going to show you what's up. We're on Ike, or above Ike, rather. We're just chilling around Ike. About 7 meters off the ground, just kind of floating here with anti-gravity. Everything's all nice and stable. We've got extraplanetary launch pads here because we are going to build something to do a little testing of beamed power conversion, and also because I want to start mining Ike and disassembling it piece by piece over the next 100 bazillion years so that we can make a Dyson Swarm. You know, usual stuff. Anyway, since the launch pad of this particular vessel, I'll close this real quick, is, like underneath the vessel, and this particular bit is a little bit too large, I decided to do a little bit of floating so that I could actually deploy this without it blowing up. So anyway, let me finalize the build here. Uh-oh. This is a problem. It is upside down. Oh no. I did this wrong. Oh no. I put it upside down. What am I gonna do? Well then. So that wasn't the best idea. Didn't work out the best. Yeah. So we tear down the build, start over, take, a little bit longer to go ahead and make this thing. So it's a whole lot of watching dials, watching the fan, watching more dials, and this thing will be done in a second. Right, okay, so we're ready. Let's take a look here. Ready to finalize the build. Just gotta work our little anti-gravity magic. Do that right there. Alright, step 1, auto hold altitude. This will take a moment to charge. I definitely should have put more radiators on this thing. Oh well. Alright. I lost my RCS on the front. Kind of blew up a little bit. Okay, let's drop down a little bit. Here we go, almost. Gentle, gentle. There we go. Very nice, very nice. Okay. Looking good, looking good. Cool. Okay. Alright, let's see if we can drop this thing without blowing up. Quick save action. Finalize build. Oh. Did we make it? Are we still alive? We are still alive. Okay. Whee! Okay. Alright, so let's very gently set this thing down. Did it work? Are we gonna make it? We made it. We made it. Okay, let's go ahead and set her down. Uh-oh. Evasive maneuvers. Oh, no, we clipped it. Whoops. Okay. There we go. These here grip pads, they're for the robotics. They're meant for your little grabber thingies, but they're great for landing feet. Keep you from sliding around on a 10% slope. Anyway, we're gonna test out some stuff here today. So this is what we got going on, and took a minute there to produce this whole thing. You know, I had to fly this out from Kerbin, fly it out to Ike, land on Ike with slightly underpowered VTOL. I should have made these a little bigger or something, but it's all good. Yeah, we're gonna have some fun with this thing right here. All right, so let's grab ourselves an engineer. Okay. Liz Kerman is going to do us the honors here of setting up our little experiment here today. Doopy doopy doo. Doo doo doo. Doo doo doo. First things first, she is going to use her super Kerman strength to push this thing a little bit further away from our ship. Look how strong. Oh yeah. Okay, that's probably good enough. All right, so let's go ahead and extend a solar panel. And extend a solar panel. And deploy big aluminum thermal dish receiver. Not that big actually, it's been scaled down quite a bit. Universal drill. I wonder if we're able to reach that. Doesn't appear that we can deploy these from here, so let's go ahead and call that good. Come on now, you can do it. Just climb on up. Okay, that's fun. We'll just jump in the greenhouse. This vessel here is designed for long-term expeditions. Naturally, you're going to want a greenhouse, an observatory, a laboratory, plenty of habitation, workshop space, and all the other goodies, plus plenty of parts to deploy, experiments. Okay, so let's just go over here to our friendo. New friend. What are you called, new friend? Micro Dave. Micro Dave is our new friend. We're going to call you Science. You're not really a probe, you're more like Science. Okay. Yeah, we're on the edge of a steep incline. It's not very much flat ground anywhere in the Kerbal system, really. Except it's like the KSC or Minmus. It's like it. Okay. We should be able to deploy. Yeah, good. And deploy. Good. Okay, so right now, looks like we are collecting power, about 3 kilowatts there from the solar panels. This bad boy right here does not appear to be connected to anything at the moment, and that's okay. It's because the receiver's not active. What if I activate it? Okay. Alright, so the receiver's active, and I'm just going to go ahead and push this aside for the moment, and let's see if we can find a satellite to link up with. Didn't quite do that right, did I? Oh, there we go. That's more like it. Okay. So we don't look like... Okay, let's turn our solar panels off. There we go. Okay, it looks like the radial aluminum thermal dish receiver component is producing the 5.8-ish kilowatts that we have available to us right now, although it doesn't say we're actually getting any. But none of that is coming from where I wanted it to come from. It's coming from Wyrks and Melt Stick. Alright, and we want it to come from the relay. We definitely have line of sight. So maybe the relay's not on. Let's go check. Okay, here's our relay. Currently connected to Melt Stick, receiving at 400 nanometers, so it's receiving at the ultraviolet or near ultraviolet range. And this thing should be transmitting. It is transmitting. But is it actually transmitting power? Let's find out. Oh, what's going on here? Maybe we should reload. Right then. Okay, so after like a day, like this is, I'm jumping back in at you like a day later. Spent some time fiddling around trying to figure out what was going on with that last satellite that you saw. Turns out my log was getting spammed with some FN radiator stuff about solar panels not being happy and whatnot, and so I was like, oh, that's not good. Alright, so I tossed the Kraft, because basically what was going on is multiple heat producing parts were all routing their heat through like a molten salt reactor before they finally got to a radiator. So bad things happen when heat, passes from a heat producing part through another part that also produces heat that is also looking for a radiator. And so that previous design you saw was so horrendous that my computer was like, I'm not even going to try to do the math on this. I'm just going to give you some null like reference something or others and then call it quits. So I restarted, tossed the Kraft, and built something more sensible that actually works and my computer is happy with. So heat all routes through and finds a radiator without passing through something else, and it's great. Alright, so what we've got here, microwave on one side and near infrared on the other. Okay, let's see, I need to flip this around so that it's facing the right direction. I got a little, make sure you put a docking port on one of these things so you can push it into orbit with some sort of tug. It doesn't weigh much. Got a molten salt reactor on here, but I want you to notice it's throttled all the way down to 10, so that it really doesn't ever contribute significantly to the power supply. Like, a couple hundred kilowatts. Lithium air battery to back things up, but basically it's just enough to keep the lights on and let it turn and stuff. But when we start transmitting, it's going to be throttled and not actually contribute to the transmission, so that we don't waste all the uranium on a relay. Instead, it'll just do some pass through. Alright, so let's try to orient this appropriately. Sorry, you have to sit through watching me try to steer this thing. I suppose I could have just done that. Radio then. Anyway, point vaguely that way, and then Ike's like up there, except it's going to be in a different position when we actually start transmitting because their base is right there. I'll also put this in a crappy orbit as well, but not nearly as bad. Could be worse. Anyway, it'll do for our purposes. So we're just gonna leave this guy sitting here. It's not on yet or anything. First, we're gonna turn on a power source. Another thing that I had noticed while I was debugging the previous situation is that melt stick here had run out of power. Because it had run out of antimatter, because I had left it just on for like ever. So, So what happened was also that poor melt stick here had run out of antimatter because I had left it on for a little bit too long. And it had just been chilling out here. So I turned the transmitter off. It's slowly charging back up on antimatter. It'll take a little bit. It's got about 122 units right now. Could probably go a little bit faster if I wasn't spinning it, truth be told. But it's kind of fun to watch it spin. Yeah. Yeah. So, probably shouldn't just be doing this all day. Got a video to make, right? Totally have to get back to the video. Okay. Alright, let's close up shop here. See you later, melt stick. Okay, let's go ahead and activate our transmitter. There's our shipyard. There's the shipyard. Okay, back at the shipyard. So the device that we're going to use for transmission today is just going to be this one that we have right here. I am in the works of building a free electron laser transmitter on the back end of this. It'll be done soon. But in the meantime, we're going to go with this bad boy right here. So it is sadly outputting in infrared, which is not the best choice here for what I'd like to do, which is beam this all the way to Duna over there. So 4 gigawatts is about what this thing can put out. 4.2 gigawatts, and it's going to be in infrared. It's actually meant for much closer use around Minmus, where power isn't really, you don't need a whole lot. So this will be funny, if nothing else. But yeah, going to beam 4 gigawatts in near infrared across the vastness of space, powered by a singularity that is capable of producing so much more, which is why we're building the free electron laser transmitter. Yeah. Okay, so let's turn that on. Oh, it's already on. Activate transmitter. It's already on. And transmission's all the way up. So let's just double check our numbers here. Consumer multi-bandwidth dish transceiver, 6 gigawatts is what it's consuming. All right. Oh, Walter beams, 4 gigawatts. Okay, whatever. It's consuming 6. It's probably only beaming 4, but whatever. We're gonna go with that. Cool, right? Okay. Alrighty, we are back here with the relay, just under Ike, in a little polar orbit, and we are connected with Punkworks Shipyard that is orbiting Minmus. Pointed at it. Anyway, the shipyard is pumping out 4.2 gigawatts over 27 gigameters. Got a 3.5 kilometer spot size. That's huge at that near infrared wavelength. All right, so our available powers, it says, is 12.1 megawatts. Network efficiency is 0.29%. And 81% receiver efficiency, but 0.29% network efficiency because we're beaming infrared light from, Kerbin to Duna. It's not the best idea, but whatever. All right, so let's go ahead and activate. We're consuming 190 kilowatts. I'm just kind of sitting here, so it's keeping the lights on. That's great. So I'm going to turn these off. I'm going to leave this up here so you can see there's the transceiver that's supplying 160 kilowatts right now. And then there's the thermal power generator from the molten salt reactor and the lithium air battery, each respectively providing 16 watts of power to keep the lights on. All right. Yeah, 16 watts is like nothing. It's like some LEDs, man. So it's just to keep the lights on. 160 kilowatts there for everything else to keep the lights on, keep stability assist, that sort of thing. And then if we start transmitting, we're going to transmit in the D-band microwave. I just picked the D-band just because you can, fine-tune those based on your actual situation, depending on what you're actually trying to do, and trust that this is the most inefficient way to perform a beam network operation or a power conversion ever. Like, this is so lossy that, just learn from my mistakes and try to do this the right way, but I'm just showing you how it works. Receiver is receiving near infrared, right? Uh-oh, we're about to lose connection. It's probably something passing in front. Yeah. Oh, yeah, look at that. That's Eve getting in the way. Look at that. Oh, and we lost it. All right. So you gotta watch out for that kind of stuff. So we'll wait for the window to come back around. we go. Yeah, let's see, we're gonna lose connection again. It was probably Gilly more than Eve, or maybe Minmus or something, but say love you. Okay. What were we doing? Oh yeah, microwaves. Microwaves. Activate transmitter. Transmission strength, I mean, I just turned it all the way up, except for just below full power, so it's actually wanting to pump out more power than I have available. So the molten salt reactor is wanting to kick in on that. So we don't actually want that to happen. All right. It's because we're not actually getting any power. I have an idea. Can I force minimum throttle? Does that work? Yes, it does. Okay, good. All right, so available power is 12 megawatts, is what we're getting off of that 4 gigawatt infrared beam. We're still getting about 12 megawatts. We're using about 10 megawatts of that and beaming 8 of it as microwave radiation out the back. Okay? 8 megawatts. Yeah. Where's Ike? There's Ike. Alright, so can we point that at Ike? Is that something we can do? Point at Ike, please. Good enough. Okay. Alright, looks like we're just about ready to do this. Except we lost connection to the thing we were pointing at. It's kind of an issue with this. I need so many more relays. So many more relays. Alright, fast forward some more. Oh, there we go. Alright, we have connection. We have connection. Alright, we're gonna go a little bit more. Can I handle that much power? Molten salt reactors still not kicking in. Okay, 20-ish watts from the molten salt. The rest of the 9 megawatts is coming from the transceiver. Okay. Alright, let's do this. Here we come, Micro Dave. Here we go. Okay, and here we are on the surface of Ike. And this is perfect because we are in alignment here just long enough for me to show you why this isn't a complete and utter waste of time. Wyrks Shipyard, the very one we saw earlier that we started beaming from, is the only one beaming right now. You know, it's 27 gigameters away, so our spot size is measured in kilometers, even though the wavelength is, you know, infrared. So starting with 4 gigawatts of power all the way down to here, let's go ahead and activate our receiver. We have available power to us of 482 kilowatts from that satellite. Now that exact same satellite is what is being relayed through Zama Relay that we saw here just a second ago. It is collecting that infrared light and turning it into microwave radiation and beaming it down here as well. So out of the 4.2 gigawatts, it collects 8 megawatts. It's a lot more than our 477. And then it takes that 8 megawatts and gives us a spot size of 9 meters at 2.2 millimeters. So we get 1.5 megawatts out of that. Now that 1.5 megawatts did originally come from Wyrks Shipyard. Okay, but direct connection from that shipyard, we get no power. But with the relay redistributing it and converting it into microwave, it's able to collect more and then convert that into something that we can actually use. So all that said and done, you know, we have a little bit of power to work with. So let's go ahead and see if we can use this to run our drill. Now, if I recall, this thing should require just over 100 kilowatts to run. 0.1 megawatts. So yeah, it should be, let's see what do we got, 125 kilowatts. Okay. Are we actually getting that though? Does not actually look like we are collecting power as I would expect. Maybe this thing has a maximum? I think we just need more power. So I think out of the megawatt and a half that it's able to get, we're actually only able to get a smaller actual portion of that as far as usable power, which is unfortunate. Maybe I need to do something. Yeah, now we're only going to get so much out of that megawatt of power that we're getting. Okay, so we're not there yet. We are not there yet. Only getting a fraction of what we're getting beamed in. All is not lost. We can figure this out. What we need is more power. So let's do more power. Okay. Sorry about all the jumpy frames, but vessel switching with all of the network stuff, the beam relay network stuff running, and recording software running all at the same time is a little much for my computer. It tends to get a little glitchy and spazzy. So sorry about all the harsh cuts, but them's the breaks. All right, so to add more power to this equation, we're going with the positron reactors attached to this little seed ship here. So it's not a whole lot. We're just gonna pump out a few gigawatts of power. 2.9 gigawatts of power. Let's bump that up a little. Yeah, 3.18 gigawatts. That should do it. Seems reasonable. Okay, so yeah, we're gonna do that for right now. I wanted to also activate a relay, but I was actually mistaken. This whole I've got this one set to near ultraviolet for the diode. If I can, that's the refrigerator, not the diode. Sorry, near ultraviolet for the diode, so it actually is not going to actually link and relay the infrared stuff. So I do apologize for that. But what we are doing is beaming out on the infrared spectrum still. Since the other one's geared for infrared as well. We're going to beam that out as well on infrared, about 3 gigawatts, and see how that does. Okay, so let's see if we can switch back to our probe now without the world exploding. Okay. Well, we have connection to the shipyard and to the relay. The relay doesn't appear to be beaming out any more power than before. That's right. I was supposed to bump that up. Alright, so let's switch to that and increase power. Okay, there. As you can see, we're getting, beam from the shipyard. We're also getting a beam from the shipyard around Duna, seed ship. So their power respectively, and also one of the relays on seed ship is relaying Punkworks shipyard, just in case a connection gets lost there. So that's how that's working. So kind of beams in. Alright, but we still need to increase transmission strength. to account for our newfound power in the gigawatt range. Okay. Oh, it's starting to get a little warm. Let's go 1.3. Oh, that's going to be a little warm. Still too warm? That'll probably hold right there. Okay, so we'll go with that for now. Does look a little on the hot side, but it should equalize fairly soon. Okay, once more. Okay, and we're back. So now, transmit power is 1 gigawatt, and available power is 137 megawatts. So let's see how much of that we are able to actually collect. Is it enough to run our drill? Activate the drill. Drill is active and running, and the radial aluminum thermal dish receiver is providing all of the power except for 1 kilowatt provided by the solar panels. Let's go ahead and retract those. Not sure where they're getting power from. It's kind of weird. Alright, so that's one. Let's see if we have enough juice to run 2. Probably not. Negative, we do not. Okay. Well, I mean, technically we do, since we have battery power, and I could run them on the lithium-air batteries, but still not quite enough to get this. What would make this better is if this dish were larger. I made this really, really small so that it would fit and not take a lot of rocket parts, but generally the normal size for this is much, much bigger and would collect a lot more, and you'd be able to actually use a lot more of that power. But I hope you gathered through this that while it is a lossy process, not the most efficient, intuitive, it's kind of fraught with a few problems, engineering hurdles, let's call them, not so much problems. You kind of have to think on your toes and do some stuff, but eventually you can beam that power out in some way, and then you can convert it on site into something more useful. So that, because if we were beaming just directly from Punk Works Shipyard, we wouldn't be able to do this. You saw we actually got some more useful, but we would still have to run on battery power, and then having multiple sources feeding the same device ultimately gave it enough juice to run this thing. So you could just beam in with multiple collectors, and then try to get something done. So yeah, I'm going to continue to develop this site and other sites and do some other cool things. And I do apologize. This is kind of a long and rambling and weird video that doesn't really have anything exciting in it. But I find the whole relay network thing really interesting, and so it's something that I did have fun, exploring. And the whole relay network thing is something that I had a lot of fun exploring, and I hope that you have a lot of fun exploring it too, and figuring out the different ins and outs and things that you can do, and how to make these things way more efficient. A lot of the same hurdles. You got to worry about that heat. You got to do something with the heat. And you gotta, optimize your transmission sources. Remember, bigger apertures. You're gonna be able to beam more, collect more, that sort of thing, and just kind of fine tune it and get way better at math than me. And then you'll have a much easier time at things than I will. All right. Stay tuned for the next episode. As always, it's gonna be based on whatever you guys say in the comments or on Discord or questions maybe on the help forums, and I'll take care of you. Peace.